So, my name is Gabriel de Dietrich. I've been working on Qt since summer 2009. You can have probably read on my biography, autobiography. First at Nokia, and then Digi, now the Qt company. I've always been part, in some way or another, of a UI team, and it's a mixed blessing, because I like when pixels look right on the screen, and it's not always the case, unfortunately, with Qt. So I get some suffering too. Currently, I'm part of the Qt controls team, and also work on the Qt Mac board. So if you see something ugly on the Qt Mac style, you know how to blame. I live and work in Oslo, Norway, which is nice, because I get to share the office with some of the very first roles that have been working on Qt for the last 15, 20 years. And as you might have noticed from my accent, I'm not a native English speaker. I'm half French and half Spanish. So maybe here and there you will hear that I stress the wrong syllable on some words, or I make up my own grammar construct, so bear with me. So today, what we're going to see is how to implement a UI using Qt controls. Also, how to interface QML with C++. And finally, how to create a QQuick compatible model, that is, because when you create a UI, you always have some data you want to show, so how to do that properly. So let's see. Switch to Creator. Okay. If you create a new QQuick application in Creator, you end up with this sort of template. Well, here I added a few more things, but basically it's this. The structure is you have a main CPP, and then you suppose you have your QML files in the resources, Creator knows what to do, you press the run button, and that's it. The main CPP file is pretty simple. We have a Q application, then some sort of creating an engine, and then we run the application. The engine previously, starts by loading this main.qml file here. Main.qml file is the one we saw here. And this is a template that you get. So you get already an application window, that's top-level window. Here is a menu bar with some menu items and some text in the middle. So if we run it, here it is, just as promised. There's no surprises. Well, this UI is a bit boring, so let's try to give it something more. Like, for instance, we can have a button. The button can say hello world. And like QtQuick controls is an extension of QtQuick. So it behaves, you use similar API, so you can do unclicked. And then you can have the button say something. Since it's a polite button, it would say thanks for clicking. So let's try again. And this is how it works. You can see at the bottom of the screen it's saying thanks. If you notice here, this button doesn't look like any random button. It looks specifically like a Mac button, and that's because in QtQuick controls, at least on desktop platforms, we support all the native look and feel. So it looks here as a Mac button. It would look like a Windows button on Windows. It would look like a GTK button on Ubuntu, and so on. And since what last Noel announced during the keynote, since Qt 5.4, it will look like an Android button on Android. So that's it. Is there any questions? No, maybe we will try to do a more complex UI. The UI we want to implement actually is this one. So we want to do Okay, no fix. What I'm going to do is create a small application that will compute and display the histogram of a picture. Does anybody know what the histogram is? Okay. For those who don't know, let's say you have a grayscale image, and every pixel on this image has values from 0 to 255. A histogram basically counts how many pixels have each value. How many pixels have the value 0, how many pixels have the value 1, and so on to 255. What I try to do here is an Rgb histogram that does the same, but for each red, green, and blue channel separated. So the UI is the following. We'll have a main window. The main window will have a toolbar with some controls in it. Then we have a split view. Split view is this thing that splits your main or some region of the UI, and then you can resize both sides, left and right. And on the other side, we'll have a tab view, and the tab view will display a table view with the histogram values, and the other tab will display a histogram view. This very simple histogram view. So let's do it. Let's clean a bit this. So we don't need the button anymore. We can also start by changing here the window title. Well, we say that we had a toolbar. So application window, we saw that has a menu bar property, so has a toolbar property. To toolbar, we assign a toolbar object the same way we assign a menu bar object. We can put a tool icon here, tool button, sorry. The icon source is going to be this one. Just let me copy paste this. And then we have a slider. And further down, we have a split view. See how we are following more or less what we saw in the previous slide, right? To display the picture, we'll just as a plain image element. We're going to call it picture. On the other side, we're going to display a tab view. Tab view. This tab view has two tabs. So first tab, we have a title that is table. And we contain, well, we can do the second tab first. And the second tab then has a title. We're going to call it histogram. The first tab then is showing a table. So we also have a table view element. Is this right? Maybe we should move the code a bit further up. Table view is, don't expect a spreadsheet or something you can use to implement a spreadsheet. This table view is basically a list view where we arrange data as columns. And those columns, you can move them around and so on, but it's basically that. So to display data in a table view, we need to define table columns. So first table view column, we'll have title here, that would be just this number sign. We can give it a default width, that's 50. Another table view column. For the red component, just give it a slightly larger width. And, oops, here and here. Same for the green and blue components. I forgot to do this. We want the split view to take the whole space of the main Windows content area. So we do that by simply filling the parent. Okay, let's run and see what we get now. This is not as nice as we could expect. But let's try to fix the toolbar first. The toolbar is a very simple element. You can have many things inside, and you can arrange them in many ways. So what we decided is that the toolbar will be just to give the visual of a toolbar, the styling, basically. And it will get the right size as well. It will adapt. It will get the window width size and whatever the style says its height should be. So if we want to arrange things inside the toolbar, we need to put whatever its contents in a row layout. Row layout is part of the QtQuick's layout module. That's what Creator doesn't like now because we need to import. So the QtQuick's layouts module basically provides that, a way of layouting stuff in your UI, the same way as Q layouts in QWidgets. Okay, let's see what it looks like now. And now it looks nice. Notice how also the layout arranges so that the icon and the toolbar look nicely aligned vertically and so on. Okay. Let's finish configuring this slider. This is going to be bin count for our histogram. So the number of bins in a histogram is how coarse or refined the histogram is going to be. We can group counters in a way by ranges of values instead of single values. So the minimum value is going to be 2. The maximum value is going to be 8. This is going to be an exponential histogram instead of linear. We want, step size, want 1. I'm going to show the tick marks because we are only interested in integer values. So this is going to be true. Now, good. So we have a slider and a button. Okay, this part here is not looking quite as good. Let's try to fix it as well. What happens is the split view. The split view is trying to set the size or the width in this case, since it's a split view. So you can have vertical split views, but this one is a horizontal split view. It tries to distribute its width among its children. The image is not saying much about how much width it needs. The tab view is saying a bit because of the style, and it knows what it contains and so on. So it's trying to fetch some dimensions up. So we can also, since the split view is setting the width, we cannot just say width here, because then we will start moving the split, the layout and the split view, and it's going to change things. But what we can do, and what you should do, is use the layout attach property. We set a minimum width, and this could be 200, for instance. We can do the same here for the tab view. So when you import the QtQuick layouts module, every item gets this layout attach property that layouts obviously can use, and the split view also uses as a side effect. Okay, let's run it. And now we see that we have space here. We're not displaying any image yet, so we're not seeing much. And our split view is working and respecting some minimum width on both sides. Good. Now, if you look a bit closer, you see that, we have these buttons here are overlapping the table view, and then here we don't have as much margin as we would like. So let's try to fix this too. Again, here what we'd like to do is do something like that. We'd like the tab view to fill its parent, and then maybe add some margins. 12. This is not going to work again because there's nothing to fill. There's no parent item to fill. The parent item is the split view, and the split view is going to be changing constantly as we resize, as we move the separator. The tab view component, the tab view width. So what we should do instead is insert an item that will be sized by the split view, and then the tab view gets its size from its parent. Let's see. And it's looking better. We have a nice margin all around. Yeah, we still need to fix this part here. Well, this part is going to be fixed the same way, actually, by adding, actually, well, we need to add some margins. Oops. On the table view. Oops, sorry, no, not on the table view. On the tab. Now, okay. So we have the skeleton of our application. Well, we're not showing the histogram yet because we don't have any data to show, the same as the table view. But if you see, we are almost done with the UI. Now what we need to add is some logic to add ways of creating things or interacting with the program for the user. So let's do it. One thing that we want to do, for instance, is open an image and display it. So, same thing as before with our plain button or push button. Now the tool button has also a clicked signal. And what we want to do here is open file dialog and pick and display image. Okay. So how will you do that? Well, this is like a box full of surprises. We also have a quick dialogs module. So, from quick dialogs, we can get a file dialog. Let's call it, I don't know, open dialog. We can set the default folder. This we need to pass a URL. User up. Now I need some help from probably this one and then this. Okay. And so what the tool button needs to do is just open dialog. Well, this name is not perfect, but and so when we click the tool button, it's going to open the file dialog, and when the user accepts some file or selects some file, we have the accepted signal emitted. And here what we want to do is just assign the picture image source property to be whichever file the user has selected, so file URL. Okay. Let's see if it works. So I click the tool button. We have a nice dialog that pops up. Select an image. We show it. See that this is not working very well. Let's try to fix this resizing. It's fill mode. It's image. Preserve as crop fit. Now let's do it again. Good. So we can even enlarge the window. So you can have. Now you're going to make you a bit jealous because this is one of the other advantages of living in Oslo. You can go to these sort of places when the weather is nice after work. It just takes 10, 20 minutes by subway and a bit of a walk. But anyway, we're here for work, not for vacation. Okay, so we know now how to try to interact with the UI. We can also do the same with the menu. So we can add in the file menu, we can add menu item. And and then the text will be open. And when the user triggers the menu item, well, we will do the same. Notice that we only need to open the dialog, and the rest is done on the unaccepted signal handler here. Let's see if it works. Oh no, magically we have this. You don't see it. No. Okay, sorry, there's been some problems with the projector. So imagine a bit slightly above the ceiling, we have a menu item opening, and says open, and then you see this again. Okay, we can open the same image. Okay, good. It's working. But if you look a bit closely, we're doing the same thing here, right? We'll be doing the same thing in the tool button and the same thing in the menu item. It turns out it's just a one-liner, but even one-liners, we want to try to abstract those things. Good news, we have what we call actions. It's very much like your action. Well, yes, it tries to be very much like your action. The actions can have a text, that is open image, can have an icon, icon, source, let me copy this. And they have also a triggered signal. I'm going to just cut this thing in here. So we don't need this anymore, and here in the tool button we don't need it anymore. What we're going to do is just assign the action property. I forgot to give it an ID. The open action. So the action for our tool button is going to be open action. Notice how we don't have any icon source assigned to the tool button. It's going to fetch that information from the action. And the menu item is going to do the same. Action is going to be open action. Also notice we like to keep a different text maybe for the menu item. So there are a few properties that can be overridden that don't come from the action. Now if we run it, we click this button, the button is triggered, will trigger the action and so on, and then we can open this other image. And same for the menu. Oh, I shouldn't have closed. Same for the, well, you don't see it again, but same happens. We can even assign shortcuts. This will have to, believe me, even more because you will not see me typing the shortcut, but shortcut, and then it's Control O. So I run, and I press Command O, not Control O, because I'm on Mac, but anyway, it maps. You already know, for those who use a Mac. And then it opens the dialog. Good. So that's it for the actions. Now we want the histogram, right? That's why we are writing this application. And we would like to introduce a histogram somewhere here. When you want to use a new type or create a new type in QtQuick, try to think declarative. Try to think what are its properties and maybe what are the signals it may trigger and how you want to react to them. So what we're going to try to do is first see how we would like to use our histogram in QtQuick. What are the possibilities, and then see the C++ implementation. So let's suppose we have a Rgb histogram object. Let's call it like this. Well, it needs an image to work with, so we have an image source. Here we can bind it, for instance, to the picture source property. It also needs, remember I said the slider is for the bins, so it needs a bin count property. And here we're going to do this bin count slider dot value. Okay. Let's suppose that the images can be rather large, or that the histogram does much more than just computing the histogram, and so you don't want to update every time you change something, and you want to explicitly say that you want to do something when the image has changed or when the bin count has changed. So you're in the right to expect an image source change, so the image source change signal to be there. And maybe then at this point you want to call some compute function that will start the computation of the histogram. Same for the bin count changed. And then you call compute function. And then you don't want to wait for the histogram to be computed, or maybe it's been computed on a separate thread, we don't know. So maybe we want a histogram updated signal. So we can expect these sort of things, and then do things here, right? For instance, we can iterate over all the values of the histogram and display them. So that so we iterate over all the bins inside the histogram, and then we display the current bin, and let's suppose that we also want accessors to get the values for each bin. So red count of I, and green count of I, and blue count of I. Okay. So this is what we would like. And then maybe we can assign it to our, here, the last tab, we haven't, oh, I misspelled histogram. The last tab, then we will have our Rgb histogram view that, as you saw earlier, I already had added in the resources. And then say that it has a histogram to display, that is going to be this histogram. Okay. So, how we do that? So, okay, this is the UI. As you can see, we're pretty much compliant with it, so we can go to the next slide. So we've seen that we wanted a way of defining new properties, a way of defining functions that we would call that could be slots, or functions that we would call that could return some values, and also signals that are not part of property changes signals. So in C++, if you want to expose a new type into QtQuick, these few steps. First, inherit your class from QObject. If you want a new property, then use the QProperty declaration. Bin count here after the type will be the name of the property in QtQuick, and then you specify which are going to be the getters and setters and the change signal. Public slots, no need to do anything. They're exposed as they are in QtQuick. Signals, the same. Just declare your signal, and they will be there waiting for you in QtQuick. If you have some function that does something a bit more complex and returns a value that doesn't fall then in the category as slots, then you just prefix it with a Q invocable keyword. And then mock will do its work and make sure everything is visible. Okay, so let's do it. Actually, we're not going to do it. I had this already prepared. Otherwise, this presentation would be a bit longer than it is. This one and this one. Okay, but let's see how this Rgb histogram C++ class is coming along. So you see we have a Q properties. The image source property is there. It's a QURL. So some of the, or most of the types already mapped, or the Q types already mapped into QtQuick. We see it has a setter that's a getter, that's called image source, and a setter set image source, and the image source changes signal. Same for bin count. And we have another property, we'll see how we use it later, and this property is read-only, so it doesn't have a setter. Notice I said it's read-only, not that it's constant. This value can and will change, but we don't expect the user to need to set it. We also see here all these accessors for the values inside the histogram. And, okay, these getters here have been, this is a nice trick. If you're using Creator and you don't want to type the setters and getters for your properties, you can just go here to refactor and generate missing Q property members. And I will generate basically this code, and it will generate the image should change, or declare the image should change signal, and so on. It also generates this setter here. And notice how when the setter gets called with a new value, we have to emit the signal so that whoever is using the QQuick type can rely on it and react to the value property change, or the property value. Well, you got it. Notice also how, that means it's a bit more manual, but it also gives us a bit more power. Notice also how we can instantiate a few things and then emit the signal so that our C++ object is in a sound state when the signal reaches QtQuick. Let's see now also. So remember that here, if the image source has changed, we call some compute function. If the bin count has changed, we call some compute function. So now let's see how this compute function works with this other signal, histogram updated. This one. Is this C++? Yes, good. So here's the compute function. We can go, oh, nice, it fits perfectly. So we test and open the image, we see if it's there, and we open the image, we clear here some internal data structures, then we iterate over the image, and then increase each bin according to the values of the value of the current pixel. And then we have this max value property that we saw before. And this is when it's going to change, because we updated the histogram, so we want to know which one is the maximum of the value of all the entries in the histogram. So basically we compute it, we go through all the bins, and at the end we emit the value change. Notice then how there's nothing automatic, it's completely manual, but it gives you the power of doing the right thing at the right moment. And finally, when everything is ready, then we can emit this histogram updated signal. So now, one last thing we need to do, and is make the QtQuick engine happy. Here we have an engine that we have instantiated, but it doesn't know yet anything about our Rgb histogram class. We need to tell it. So we're going to include this QtQML file and also include our Rgb histogram here. And after we have instantiated the engine, we're going to register. As you can see, there's plenty of register. You can tweak how you want to register a type. But we're going to go for the simplest one. And this is a template function, so you just say, I want to register for this C++ class. I want to register this import. Let's suppose we're working for the startup. We call it pixmix.io. So we use the reverse URL notation. And this is probably our image analysis module, version 1.0. And finally, the name of the type in QtQuick. There's nothing wrong in giving it the same name as the C++ type. Okay, so this way we say So I can recapitulate. This what we're saying is to the QML engine is take this C++ class in this import for this version and call it this. Okay? So now the engine knows about it. Now the last step is for our application to know about it. So what we're going to do is just import our image analysis module. Okay, let's give it a try. Oops, thank you. Uh-oh. One line below. Below which? Which line number? 16? No. 60. 60. Oh, thank you. Yeah. This is some of my Norwegian proving out. Okay. Well, this is the UI you've seen before already. We can open this image. This is, well, this. All right. See how we are down here displaying, for those who don't know, we'll have to, I can try to move this up a bit more. Okay, we are displaying the histogram values. So we got some data to display, but which one is it? And if we switch to the histogram view, okay, this histogram doesn't look much like much, but there we go. So this is a histogram. So it's working. It's good news. So we just saw how changing, this is very much slower than I was expecting. Oh, I think the image is larger than I'm used to use. I don't use last-minute images for your presentation. If you need to do it. Let me open another image. It will be a bit better. Back to this one. Okay, now it feels much better. Okay, well, you just saw. We changed the bin count, the histogram updates. We changed the image, the histogram updates. Everything that works. Okay, now we still have this table view here. It's a bit sad because it has nothing to show. So we're going to help it a bit. So table view, it's a bit incomplete here. It needs a model. Let me scroll a bit further up. It needs a model. Let's suppose we have a histogram model here. And as I say, table view is basically a list view where we arrange data in columns, as you have seen on the screen. So for each column, we need to assign what we call a role. And this is going to fetch this role from the model and display it on this column. So the role for the first column, we can call it bin number. And the role for red, green, and blue columns, we're going to call them red, green, and blue count. Green, yeah. So green count, red count. I'm a bit red count, green count, and blue count. Now let's quickly create this model, because we don't have one. We can do this. Now, I'm trying to see. There's no danger. I can show you this. This is not the most efficient way of creating a model. In fact, some of my colleagues would tell my boss to fire me if they saw me using this technique in production code. But actually, no, there's nothing really wrong with this. Just not efficient. And actually, it's very useful if you are prototyping some view, you need quickly some data model, and you want to do something. So we start by doing the model, and then we iterate over all the bin counts. And I shouldn't have. Let me keep this line because I don't type very quick, so no need to So his model clear. And what we want to do here is model.append, and then this, and then this, and this. And basically this is just, we're appending a JavaScript object, so we need to give it some properties, number, bin number, right, and then red count is going to be this, and then green count is going to be this. There we go, next line here. And finally, blue count is going to be this. So we have a list model. For those who know it already, it's a very simple linear model where you have, usually one of the ways of declaring data is saying list element, and then you define here property, colon value, and so on. But the other API is to use this append function. So we define a row entry basically for a table view, and each row has 4 different roles: bin number, red count, green count, blue count. Let's run it. Let's open an image. And there it is. So it's displaying data in our table. And same as before, notice that when we change the bin count number, we have more data in our table view. We change the image. Let's go for this one. Same, it updated the data. The histogram still works. So we have this very nice sort of model view controller thing. Okay, but this, as I said, it's not very efficient. We want the real thing. What we would like is have here an Rgb histogram model, and then have a histogram property, maybe, and then assign standard histogram. And this will generate a model. And we shouldn't need this anymore. So how do we do it? One of the solutions would be to take our Rgb histogram, and instead of inheriting QObject, we make it inherited QAbstract list model, because it's for a list view, so we need to inherit QAbstract list model, and then implement the QAbstract list model interface, right? Well, as we all know, it's not a good idea. You don't do such things. You have one class does one thing, one other class does another thing. So Rgb histogram does the computing part. The model is going to be the model part. So what we want is that if we have a C++ object or any other sort of class, and we want to make it communicate with some QML model, and then the QML model, we can use it for a table view. And what's going to happen is that when the C++ object is updated, it's going to emit a signal to the model, and the model is going to say to the table view or any other view, hey, I have new data. And then the table view is going to come back and tell the model, okay, then give me data for this row. And the model that is smart enough with the C++ object say, okay, histogram, give me this data. So this is what we're going to do very quickly. Add existing file. It's so quick that we only have a header file. So here we have the same. We have a Q property that's going to be our histogram. That's a reference to our Rgb histogram. Notice that since it's a C++ object, then it's a pointer that we pass. We say, actually, you should read it like this, even though it's not our coding style practice. But basically, it's this. And so that's how you expose any C++ class in QtQuick. We have a getter, a setter, and a histogram change. So if you used to QtQuick no, sorry, not QtDD items. Item views. You know what that you need to implement. You define some roles for your model, and then here is how you map your actual roles to the role names you give in QtQuick. The row count is the same. This is how you fetch the data. You get a model index, and then you tell the histogram to give you the value for the current bin. And finally, you need to react to the histogram changes. So notice here in the set histogram, so in the histogram property setter, how we connect the histogram grid path, the histogram updated signal into our own histogram updated slot. Could have found a better property name or name for that, but anyway. And here, so this is our histogram updated slot. What we do is we just reset the model and name it a data change that the table view is listening to and saying, okay, we just got all updated. This is not a very smart way, but you can make it as smart as you want. Okay, let's see. We need to do here the same thing, also expose this type to our engine. So we're going to do this. Since we don't have here, model. We could have a different import here we wanted, but it's up to everybody. And then let me double check that our histogram model, okay, this should work. Let's give it a try. Okay, there are a few changes now since we have a model assigned and it already has some values it can show. But for instance, let's open here our beautiful image and see how the model values have changed and how, as we change the bin count, also we add more data to the table. And our histogram still works the same. So that's basically it. I think we're done with the UI. It's working. We've seen how to plug logic, how to implement the UI, how to plug some logic into the UI. We also have other, I don't want to be embarrassed. We also have other controls, obviously. We have scroll view, split view, what you've seen. We have piece indicators, all sort of buttons, checkboxes, and text inputs. All you need, this is all the other QQ controls. You can find this in our public documentation. And we also have another model that is enterprise only of more embedded oriented, let's say, QQ control. So that was the 1 minute marketing from me. That's it. Thank you very much. Okay, so I think we have a few minutes for questions.
Any time for questions, but 10 minutes.
If you have to do this for several resolutions, you can say with 200. So you must have a percent or...
Yes, we don't have a clean solution for this yet. Notice that this is a Retina Mac, and it will look exactly the same dimensions on non-Retina Macs. And so we have some preliminary support for that, and it's been announced a bit already during the keynote. Right now, the only thing I can tell you to do is to try to make visible from your C++ code a property that will say, okay, we're going to scale up things like that. Hopefully 5.4, 5.5, we will have better API. Yes? Or? Sorry?
Is there a reason that there are no tree views?
Oh, yes, the reason is that they're not implemented yet. This is on top of QtQuick, right? You know, QtQuick only has a list view, and then also has a grid view and a few other things. But QtQuick was originally developed for mobile, It was developed during the Nokia days. So we're trying to bring things up for desktop. So yes, the table view we had to implement, and it's fully implemented in QtQuick, so you can already do nice things with it. Preview. The good news is work in progress. The better news is that it will probably be, or most likely be, as a track preview early next year with 5.4.1 or something like that, and we hope to have it in 5.5. It will be pretty much the same kind of preview, so, with this table view. Yes, please.
In QWidget, compared to this table view, there's the possibility to change the size of the columns and the position of the columns. Is there not the same thing here?
Yes, like this you mean?
Okay.
Yeah, and this, you can change the position as well. And you can do that programmatically too.
Can you show up the implementation of the histogram view itself?
Oh, yes, if you want. It's a bit hackish. It's very simple. So we have the histogram property here, and it's basically a row with a repeater with rectangle. So it's nothing from outer space. And this is where I needed actually this max value property to normalize the height of each rectangle. So there's nothing. It could be done in a much more nicer way, I guess, with Canvas, for instance.
In some quick item implementation of course approach.
Yeah. Yes?
On the keynote, there was said that some type of enterprise control. Is this an extension to this now?
Yeah, this is those here that I showed. It's a paid extension to those, and they're the same, yeah. And except that they're more oriented, as I say, they're more oriented for embedded devices and touch displays.
Is it part of some commercial licensing? Or?
Yes. Please.
Are the standard dialogues not fully implemented in QML?
Good question. Most of them, yes. I think you should have, even on Android, we have dialogues. So I think, I don't want, okay, but this is 5.3 documentation. But I think most of them should be implemented by now for 5.4, yes. I need to double check, but yes, I would say yes.
Is it possible to apply style sheets to
No. What is possible to do is to style them yourself. It's all QtQuick. The style is QtQuick, the code is QtQuick, it's all the same. So we have here, this is our demo, our main kitchen sink demo for QtQuick controls. So here you see a bit everything, the buttons, something with a button with menu, we have combo boxes, whatever you want. And so also you have styles. So what you do is you override, you declare a new style for it, and you override it. And so you can have buttons that look like this with things, and plenty of other things. We can even have graphical effects inside the style. It was a bit too much maybe, but yes, you can style. There's no style sheets, however.
So it's basically re-implement.
Sorry?
You re-implement now the controls with some different.
No, it's not re-implemented. For instance, the button here. Let me see. Main QML. We have, let's say, we have a button here. It doesn't matter. And the button it still works the same, right? So you only have a style property, and then you say that button style, and then you implement. Yes, sorry, you need to import. Let me see, maybe I have a.
You go to documentation.
Yeah, exactly. I don't remember where. Here. So this is basically all the controls that you can style. And for button style, for instance, you can implement the background and the label that are components. The control here property is a reference to the button itself, so you can read off properties here. Please. You need to use okay, the question was if I want to sort the table view, right? Yes. How can I do it? The answer is you need to use a proxy model. There was a blog by one of my colleagues, JP Nurmi, that explained how to use a proxy model to sort. You can probably find it in the Qt project blog or the DJ blog. It's a few months, no, it dates from early this year. Okay. Fine. Yeah, I don't. Yes, I think. Are there any other questions? No? Okay, thank you.